In this problem, we're going to be solving a quadratic equation using a method called completing the square. And the setup, the way this problem is already set up, it's got the quadratic and linear terms all together on one side, and then the constant is all by itself on the other side. So um, if it was the case where all three terms were on the same side, you still would want to move the constant to the opposite side. So the first thing that you want to ask yourself is, what number completes the square for x squared minus 6x, right? That's the question. So the first step that we do is take the middle term, and in this case it is a -6, and we want to multiply it by 1/2. And the result of that will give us -3. The next step is to take the result of step 1, in this case -3, and square it. And that results in a +9. So now we're going to add this value to both sides of our equation, of the way it's written. So let's see, x squared minus 6x plus 9 equals to -1 plus 9. Okay, remember that these came from our two steps here. So now we let's go ahead and clean this up. You get x squared minus 6x plus 9 equal to +8. And the left side, that's a perfect square trinomial, so I can factor this, where I end up with x minus 3 squared, and then on the right side it's equal to 8. So I can take the square root of both sides because I want to solve for the value of x. So to get rid of this squared on the left side, I just take the square root of it. But I also got to do the same thing to the right side. So the result is x minus 3. So I have the square root of 8, but 8 is not prime. It breaks down into 2 times 4, and then 4 breaks down into 2 times 2. So I have a factor pair of 2, one factor pair of 2, and then a remaining factor of 2. So I'm going to end up with 2 radical 2. And when you take in the square root, you have to take into account for both the positive and negative roots. So finally, I'm solving for x, so I want to get x by itself, so add 3 to both sides. And when I do, put this in the front, it's +3 plus or minus 2 root 2. Okay? And these are our two solutions to this quadratic using the completing the square method.